Welcome to another Defichain source code analysis video. First of all, thanks for all the positive reactions and sharing and everything on the first video. There was one suggestion or one question in response to the first video regarding how the liquidity mining rewards are distributed and how it looks. And I looked into that and found out that it's quite interesting and not that obvious. So there's something to learn in there. So let's look into that and make this video about how liquidity mining rewards are distributed and how it looks in the chain or in the source code. So first thing where we start is this method connect block. It's in validation CPP. As always, I will put the references and the links directly in the description. GitHub has this nice feature that you can directly link to a code line or a block in the code directly into the repository, so you can directly click on that and see all the steps that I mentioned in the video now. So this connect block, as it says in the command here, this basically, when a new block comes in from the chain, from the network, the node takes this block and with this method applies all the changes that this block contains to the chain. Within the block, we have the transactions. So we have in there what happened, what transactions from to custom transactions and everything. We apply that. And also what it does in there is do all the things that happens with a block. They are not necessarily part of the block in terms of they are saved in the block in the chain, but they are part of the consensus, like the liquidity mining rewards or the Coinbase, where we say, okay, this is some stuff that happens every block, and we don't need a transaction for that because we know it happens every block. And this is also done in this method. So this method is the first stop if we want to see how liquidity mining rewards are distributed. So if we look at this method, it's quite a lot what's happening in here. Luckily, there's also a lot of documentation and comments on why stuff is happening and some references. And you have to scroll quite some bit, so it's a pretty long function. What's going on? And wait, there we are in 2.7.15, where we see update pool rewards, and that's already something that's interesting. And that's basically where this thing happens. It's the only thing where pool rewards are really happening, and it's a method called on the current cache of the current chain state, and this method is called with two functions. So you can call it callbacks or lambda functions. One for the owner rewards of the pool owner, and the other for the on transfer, it's called. It's basically when within this function we want to transfer something from a script to another script with an amount. It's happening here. So it takes balances from the from and adds balances to the two if any of those happens. Why this is done like that, we will see in a minute. So this is the thing that's happening in this connect block. So let's look into this update pool rewards, and it's in the pool pair CPP. Here we have the update pool rewards. As you see, there are two functions coming in, and in here the first thing that's noticeable is we have some logic of there was a change in the reward calculation and a change in the whole reward logic, and also there we got new custom rewards with the Clark Quay, how we call it, and the Bayfront had a new reward calculation, and the main thing is with Eunos, where we had a whole new reward logic. But spoiler alert, we'll come to that later. So first look into the how we did it previously, or because that's kind of the straightforward way to do it. So it's the easiest to understand and how we expect it to be. So we go in this update pool rewards. We do say for each pool ID, so for all the pools that are in this on the chain right now active, we go in, we have the new custom rewards. Custom rewards are some special thing, so let's not look into that today. We move on and say, okay, here we get the total liquidity and everything, and the pool reward for this pool, and then we have this. If we do the new pool with new reward logic, as we said, after Eunos, new reward logic, before is the old reward logic. So let's look into how it's done before first. Here we are in the loop where we say this is executed for every pool, and now we say for every share of this pool. So for everyone who has a liquidity token of this pool, so that's the provider, we do the following. So we check if it's current, we say how much liquidity does this provider has. So for this pool ID, this provider give me the balance. Then we calculate here the weight of this owner, so the percentage, how much share this owner has in this pool. So my liquidity divided by the total liquidity times the position. And that's the old calculation of the reward logic. This position is the 10,000 that we had up there, but we are looking into that. So then we have the calculation if there was a swap event of the liquidity of the commission rewards. So here you already see new reward logic, new reward calculation, sorry. That was the first update. That the old reward calculation is with the position. We say, okay, first we calculate how much weight do we have in this pool, and then we say we scale it up by 10,000 so that we prevent floating point operations, because that's all, as you see, all in integers, but still that we have a position in there, and then say, okay, all the commissions that we got in asset A times my weight divided by position. So we scale down again and we back to the normal amount, and then use it. The new reward calculation just does this in one step, and internally it scales it all down to 256 bit calculations, and then after the calculation scales it back down. So it's just commission A times liquidity divided by total liquidity. It's happening in there, just scaling it up, preventing floating point operations and still staying in a precise calculation. So that's just a new reward calculation to be more precise and less error prone. Yeah, and we distributed, we have this on transfer here, and as you see, this is the on transfer that was given in. As I said before, this is this function that we give in, where we say, okay, we transfer from to this amount. As you see here, we transfer from nowhere because rewards are distributed or created out of thin air. For the fees is a bit different because this is the fees that are paid by the user when they do a swap. It's burned and well, it's just removed, so it's just gone. And here we create it back out of thin air, so it's no checks and balances between that. It's just in the code that it's the same. That's why this is kind of looks like it's out of thin air, but in reality it's not really out of thin air. But here when we look into the pool rewards, where we have to, okay, if we have a pool reward for this pool, again, the new calculation with the helper function, old calculation with the position and the weight. And then here, this is really provided out of thin air. It's just newly created reward in DFI, provided reward sent to the provider. And we sum up that we say, okay, we know how much we totally distributed. We can have that for calculations and statistics. And then that's it. In the old way, this is how the whole thing was, and the balances, the custom rewards are also transferred. And this is how in the old version, before Eunos, this was distributed. Kind of straightforward. On every block, go through all the pool shares. For each pool, go through all the pool share, everyone who owns a share. and give everyone on the balance their share. Now, the thing is, if you do it like that, it's correct and everything, but it takes a lot of computation time, because on every block, so roughly every 30 seconds, you have to update every balance of every owner of a liquidity push token, which is a lot of owners, a lot of wallets that needs to be updated in your local node, in every node. But the thing is, most of the nodes, if I have my own local node, most of the blocks don't care what's the current exact balance of this wallet. I care what this balance is as soon as there comes a block in the transfer stuff, so that I can verify, okay, is this owner or is this wallet allowed to send that, because do they have enough? Then I need to update the balance, then I need to know the balance. But this happens for a few wallets per block, so most of the wallets don't need update every time. That's why it makes more sense to say, okay, we don't update that every block, but only if we have the need to know exactly how much tokens and what's the balances on this wallet right now, because we want to send something from there or do some calculations on it, then we need to update it. And the thing is, we don't need to update it every block so that we know it in the future, because in the future we can say, we already know for each block in the past how much liquidity rewards has been or would have been distributed on this block. We know the share of the token, how much liquidity tokens this user had, what was the total liquidity in this pool at this time. So we know all that, so we can calculate it back and then update the balance once for, I don't know, 1,000 blocks at once for this balance, and do the calculations once, which is far more efficient than do it every block every time and do all the stuff. That's why this makes far more sense performance-wise. It just you need to make sure that you really update it every time on every block, on every occasion where its balance is necessary. So that's why what happened with the Eunos update, basically. So in a new reward logic, and here it looks a bit weird because in the Eunos logic, a lot of stuff fall out. All the stuff that's done here is not there. It's just that we say, how much did you distribute this block? How much pool rewards do we have? And these custom balances are taken from the owner, the custom rewards. But there is no distribution to anyone. And first to think, wait, no more distributions in Eunos, but that's the thing, there are distributions. So side note, if you want to find out how this happens, because that's what happened for me when I looked into that, I was like, why don't we distribute stuff in Eunos? Then I looked into the source code, checked where this change came in, and found out that this is with the Eunos update, which makes sense with the new reward logic. And then checked through the Eunos, through the merge of the major Eunos, what pull requests came in, and in this pull requests, I found that there was some change in reward logics. Checked this pull request, and there I saw the new logic that is happening and where this is happening. So let's look into where this is happening. Basically, we have now, since Eunos, this calculate owner rewards, which says for this address to this target height, make sure that the rewards are there. I'm saying make sure and not calculate, because it could be that within one block we have multiple locations where we need to calculate, where we need to make sure that is happening. Then we go in and say, okay, when was the last time we calculated that? Is the balances height, so the height until the balances were calculated, is this already my target height? If yes, nothing to be done here. If not, we go through all the pool IDs, get the share when we calculated last time, and then we have the beginning, and we calculate the pool rewards. And this is the function we look into right away, or soon. We calculate the pool rewards for this pool ID with my on liquidity callback. Where is it? Here. This is the function. And from the this height to this height, calculated And if you have a reward for me, I give you this function, and this basically adds balance to me as the owner. This amount is added. So basically, and this calculate owner rewards is now calculated every time we need to make sure that the balances for this script, for this wallet, is correct. So what's open is, how is this calculate pool rewards happening? As I said, we expect it, based on this method, we expect it to be for this pool ability, go from there to this head and check if there's any rewards, and if yes, then call this function so that I get the rewards. Well, this is the calculate pool rewards, this method. And if you look in here, we already see something that's familiar, this position that we had before, and new calculate from garden. And we go in, we have a bit of liquidity stuff for this stuff, some calculations. And then we have from the beginning head to the end head, go in, and basically, if we have a pool reward, again, new calculation head, old calculation as we had before, new calculation as we had it before, as we had it in the old way of calculating it. And however we come out, we have a provider reward, and we say on reward, this is this callback that we gave in. Give the reward, DFI this reward. Thank you. And we get the reward. Same for the commissions, calculate the commissions again, old way of calculating it, new way of calculating it. And then if there's a fee, so a commission that we get, pay the reward. And this time first, here this is Coinbase. This is created obviously in this has the type commission, sent to the address and the custom reward. So basically it does exactly what we expected, sends, calculates the rewards for the time between this block and this block, and distributes it. So exactly what's happening. The only thing that really needs to be made sure is that this method is called every time when something on this balance, when we need correct balances for an address, but only then. That's a nice thing. Not every time, but only when it's necessary. So a lot of performance improvements made it much faster. That's why Eunos was such a big upgrade. Had some troubles, but yes, that happens. So basically, we're at the end of the video. I hope this gave you a bit of a better insights on how liquidity mining rewards are done, what changed with Eunos, and yeah, how this whole thing works. Again, if you have any questions, leave a comment. As you see, I like ideas and recommendations, and I like to look into the stuff and then give you an update on how it looks. If you like the video, thumbs up, subscriptions always appreciated. And with that, see you in the next video and have a nice day.